This is a quick tutorial for the internal resistance of a battery lab. Over here you can see that I've already set up a simple circuit in my PhET simulation. This circuit must contain a single battery, a single resistor, an ammeter that's connected in series with the resistor, and a voltmeter that's connected in parallel with your battery. You're going to then check on your values so you can see the values that this external resistor and this battery have. They are currently set at the PhET default values of 10 ohms and 9 volts. Next, in this lab, we are going to be looking at the internal resistance of a battery, so we need to set this to have some internal resistance. To do so, you're going to open up this menu on the right-hand side called Battery Resistance, and then choose a battery resistance from this slider. You can choose anything between 1 and 10. For this demo, I'm going to choose 7. You can see that that has now updated in my display on this battery. For the value is showing 7 ohms. That's the internal resistance of the battery. Next, I'm going to change my EMF value for this battery. Right now it's set to the default of 9. You can choose anything between 1 and 120. For this demo, I'm going to choose 60 just to go through here. This 60 volts is not the terminal voltage of the battery. Instead, the terminal voltage of the battery is represented here by this voltmeter. That's what's measuring the voltage between these two terminals. That's the potential difference that's actually being given to the external circuit. A lot of this is being dissipated by that internal resistance currently. This 60 volts is your EMF. Your 7 ohms is your internal resistance. You should write that down somewhere in your lab so that you have it to reference later on. We are not going to be changing those. Instead, through this lab, we're going to be changing our external resistance and seeing how that affects the two measurements shown here in these different ammeter and voltmeter. So, over here in my Excel spreadsheet, I have already created this table. This table, I have given you 6 different external resistances to test, and then write in the current and terminal velocity or terminal voltage that you see for each of those. To do the first one, I'm going to just click on the resistor and then use the slider to change that to 2.5 ohms. So I can see that updating here in the value. I can measure my current now as 6.32 amps, and the terminal voltage is represented in this voltmeter. That's 15.79 volts. I'm going to adjust my slider now to 5 ohms and then record for my second row of data a current of 5 amps and a voltage across the terminals of 25 volts. I did this ahead of time, so I'm just going to copy in the rest of my data. You will just continue this process, changing the external resistor and then making those measurements. Now that I have this data table completed, I want to graph this data. I want to look at a graph comparing current to terminal voltage. So you are just going to select these last 2 columns. Do not select your external resistance. That's just to give us some guidance in what data measurements to take. Here I'm going to insert an XY scatter plot. If you are doing this on an iPad, this is going to look slightly different for you, but the process is still the same. You should see an XY scatter plot that looks very linear in this negative regression. I'm going to add a trend line so that I can see that path going on a little bit more clearly. And then I'm going to add an equation to that chart so that I can see the mathematical model for this. Again, if you are doing this on an iPad, the app, the process is a little bit different. You'll need to go into layouts and then select the XY scatter plot layout that already has a trend line fit to it. So here I can see this equation. There are 2 main features of this equation. It's the slope, which is about 7, and a y-intercept, which is about 60. If I minimize this, looking at that equation again, I made that too large. That's okay. Looking at that equation again, now referencing our battery again, you should recognize those values. Again, we saw a slope of -7 and a y-intercept of about 60. Those values correspond to values in our battery. So that means that Even if you didn't know these values, if you are able to collect data going through here, you should be able to determine what that battery is set at. So once you have had a chance to do this with your own numbers, this lab will show you a couple different example calculations or example measurements. And your task is to analyze those in the same way that you analyzed and created a graph shown here. And then take that data to predict what is the battery's setup, so you can then test to see if you are correct, if you have the correct EMF and internal resistance for that battery.